a product, correct? If we were doing this part, T will be a course. Okay. So now what will our code look like? Let's start writing for each. So for each data row, dr in dt.rows. Okay. So we will first create one object of this. T. Suppose T1 equal to new T. Okay, since we need to create an object of this type T, right? Do we need a constraint over here? I remember last time we discussed that what will happen if somebody called this with an integer? There's no such thing as new int, right? So we have to put a constraint where T gives us a constructor. So the T has to give us a constructor, effectively meaning T has to be a class, correct? Okay, so we will do T1 equal to new T. So now if this was a student, right? So think of it this way, if T was a student, we have written this code over here. What's the next thing we need to do? We need to say T1 dot student ID. Okay, but what if somebody called it with course? Then there's no such thing as a student ID in a course. So this is where we are running into a problem. What should we do to this field? Because this keeps changing. Okay, so let me give you one more advanced programming concept. Okay, there's another advanced concept in programming, and it's called open-close principle, or sometimes also written as Liskow's substitution principle. Okay, so this concept was developed by a very famous computer scientist. Her name is Barbara Liskov. Okay. So anyway, she wrote a complicated research paper with a lot of theorems and proofs. If you read it, you'll be totally confused. Okay. So I'll explain it in very, very simple terms. Okay. In very, very simple terms, both open-close principle and Liskov's substitution principle basically mean is let a class do its own work. Or in other words, maybe a slightly better way of saying this will be do not do work of another class, okay, on its behalf. Okay, or if I can explain it even in better terms, do your assignment yourself. Don't hire somebody to do the assignment. Okay. So anyway, still this may not be very clear the way I wrote it. So basically what I'm trying to say is, okay, if you take a look at the code that I'm trying to write over here, I'm trying to basically populate fields of some type T, correct? And type T could be a student, type T could be a course, correct? So this is where I'm trying to say, we have nothing, this code is being written in a totally different class. Let's pretend we can write this method in a class called utility or something, okay? So this class has nothing to do with the student class or the course class, right? However, we are trying to populate fields of student over here or fields of course over here. So that's the mistake we are making, or that's where we are violating the Liskov substitution principle. So if we needed to fill the fields of type T, we should ask type T to do it, okay? Now, similar to this, I don't know if you recall when we were looking at I-comparer interface. Okay, remember the job of the comparison? We could have done, if you recall, I forgot if we had created like a student comparer or some extra class that we had written where we were collecting the field to sort on. Okay, so we could have done the decision to compare two student objects in this new class, but instead what did we do? We delegated the work to the original class. So again, why? Because that's a very, very important fundamental principle in software development. If you violate this, you may get it to work somehow, but in the end you'll end up creating a giant mess, okay? So anytime there's a comparison that needs to be done between two class objects, anytime we need to populate fields of a class, let the class itself do it. Don't try to do it in somewhere outside of that class, okay? So to satisfy Liskov's substitution principle, we will not do it like this. We will say, for example, T1 dot, let's pretend there's a method in T1 that we will write called setFields, and then we will pass it the data row. Okay, so now let's go to the, if T happens to be the student, okay.
Excuse me, Professor.
Uh-huh.
In that convert to list method, what is that, the second T?
What is this T?
Yeah.
Okay, anytime we write a generic method, after the name of the method, if you were calling this type T, you have to put T over here. Otherwise, if you don't write it, it will give you an error saying, what is T? There's no keyword called T. So now we are basically saying type T is the generic field. So this will be returning a list of that T. If you forgot, like go back to when we were writing the swap function or the exchange function. Okay, so we had written it something like this: void swap and ref T1 ref T2 or something like this, right? And what is T over here? We had to indicate after the name of the function. Okay. Anyway, so now we will delegate the work of populating it back to the student class or back to the course class. So if we go to the class called student, what's our responsibility now? To write one extra method called setFields. And what will be the parameter over here? Data row dr. And what will the code look like? It will say this dot student ID equal to dr of student ID and typecast to an int, and then this dot first name and so on. So in addition to all the 5 fields, you will add this extra method over here, right? So once we did T1.setFields, you will see this will end up populating it, right? What if now somebody triggered this method with the course, with the, they wanted to convert the to list of courses. Then what do we have to do? Type T. So let's go over here. Okay, so now in our class called course, what's the responsibility that we have now? To also write a method called
void setFields.
So I forgot public. So public void setFields.
Data row.
data row dr, and again
This dot
this dot course num
let's say
equal to dr of
and yeah.
course num, and if it is a string, you will typecast it to a string, right, and so on. Okay, so now take a look over here. If somebody triggered this method convert to list, and they wanted to convert it to a course, this data table to a course, right? What will be type T now?
Course.
Course. So T1.set field, so which class, which method will it call on?
Yeah.
The course. So we'll pick up the correct fields over here. If this was called with student, it will call T1.set fields on the student. So it will, so every class knows what fields it has. So this way we can overcome this limitation by, and also satisfy the Liskov substitution rule, right? However, there's one last problem with this. And the problem is, suppose you created the student class, okay, and you wrote this method called setFields, right? Now somebody can easily, towards the end of their get enrollment, they can call this convert to list method, okay, and it will work, okay? Now let's say somebody developed the course class, and let's say they misspelled it. They misspelled it. They made it set field. What will happen now? Okay, the compiler will not catch it, right? Because type T could be student, type T could be course. So you call it on the student, it will work perfectly. You call it on the course, what will happen? It will generate a runtime error saying there's no set fields over here, right? Okay, so so this is where the constraints can be made very powerful, so that we won't even let it compile if somebody did not put the proper name over here. Okay, so easy way to take care of this is create an interface yourself. Let's call it iPopulateRow, and define one method in it. Remember, in an interface, we don't write public or private, so you will simply say void set fields data row dr. Okay, so once you have declared this iPopulateRow, right? Then what you will do is you'll come to this code over here. You will provide one more constraint on type T. That type T not only has to provide us a constructor, type T also has to implement iPopulateRow. So now we are saying type T should give us a constructor, type T should also implement this interface, right? So what will happen now if somebody tried to call this, write the code? Where did our course go? Convert dt to st list. So let me write it over here. So somebody tried to do now. We can make it public static over here. Okay, so now if somebody tried to do something like utility dot convert to list. Okay, course, and let's see, our data table dt. So somebody tried to do this and try to store it in list of course, and let's call it C list. Okay, so if somebody tried to write this code, in get all courses, right? What will the compiler check? Compiler will check somebody is trying to call this convert to list, correct? And it's trying to call this on which class, which generic class?
Course.
Course. Okay, so course is over T. Does T implement IPopulate row? If you misspelled it, set field, and you never said class course IPopulate row, compiler won't even let you compile this. Okay, so now it is mandatory that if you are triggering any type of code like this, you have to put IPopulate row. Okay, which means as you try to implement, you right-click on it, quick actions, implement interface, it will automatically type this correctly for you. Okay, so now this code will work perfectly. So you can, if you were, let's say, writing the get enrollment, and at the very end, after you issued the SQL and obtained the data table, you wanted to convert this to a list of student. What will your code look like in this case? Again, you will call utility.convertToList student dt, and then you'll store it in a list of student, right? So this is a little bit advanced. I'll give you more details on Wednesday to go and create a proper full application, and then you will use these concepts to create a proper repository class, proper data access class, and then hopefully you won't be afraid of the generics after this one. Okay, all right. And as I mentioned earlier, you know, there are generics available in Java, generics available in C, or templates available in C++, but once you see how constraints are put over here, you'll see this is a lot better than the other languages. So.